Hello, we are TeamZero, CANSET team, and we are participating this year too. Our team members are David Verush, who does the software, Adam Tiani makes the 3D model, Gergő Vacsi is in charge of the sponsors, Levente Fabian does the electronics, Bálint Shanta and I, Attila Fejregyházi, do the outreach program. The SAS Skywalkers rocket building team also help us this year as our CANSET lab. Our secondary mission is to tell how an area will be affected if it would be afforested. To do so, we include a camera in the CANSET and aim it to the ground. Then we measure the area where trees can be planted. Also, we use a CO2 sensor to measure the current level of CO2.
My name is Gergő and I manage the financial side of this project. I contacted Etisco, who agreed to sponsor our team, therefore becoming our main sponsor. We also received monetary help and equipment from the Szeged Center for Vocational Education and Training, which boosted our efficiency along with our ability to make prototypes faster. Regarding the test of our satellite, we tried arranging various test opportunities, including the CANSET being thrown out of a plane. However, it would have taken a long time to get everything authorized and make the dropping legal. Another chance of a drop test is still under discussion with the Szegedi Votive Church. Our CANSET was fully designed in Fusion, therefore we had the chance to run GeForce and other types of tests. We will also carry out these tests in real life just to make sure everything meets the requirements for it to be launched.
Let's talk about our website. It consists of information about last year's and this year's competition. You can read about our team, missions and design of the CANSET externals and internals. Also, if we get to launch our CANSET, there will be live feed data directly from our device. On our blog, you can read our monthly recaps which we write every month or two. We are currently active on 4 different social media sites. You can check them out on teamzero.who/links. We documented all the events we attended.
My main task is designing and testing the shell of the CANSET, which will protect the electronics and other components inside it. The housing is 3D printed out of polycarbonate, a strong material which can withstand the impact of landing. Inside the shell are 3 blocks or holders. The bottom one secures the camera in place, the middle one holds the batteries and connects everything, like the shell, bottom and top blocks and the arms together, and the top block is an adapter so the PCBs can be secured. The arms connected to the battery holder are not made out of plastic because it would be weak, instead it is made of iron to secure the inside blocks to the cap. The cap seals the top of the shell and has mounting holes for the parachute.
Our CANSET uses the ESP32 microcontroller, which we programmed with C++ through the Arduino API. Our device has 3 operating modes, which are awaiting launch. In this mode, our sensors and GPS position are read about every 10 seconds and sent via LoRa. Active. In this mode, all the sensor and GPS positioning data is read as fast as possible and transmitted to the ground station, while another ESP32 is taking pictures of the ground. This mode will be activated when our CANSET is placed into the rocket. The last mode is receive. This mode is used so our device doesn't run out of battery quickly. Sensor data is read rarely. Positioning data is sent every 5 seconds, and the captured images are transmitted to the ground station.
To house the electronic components, I've designed 3 PCBs. The top PCB has the main ESP32 and all of the sensors. These sensors are a BME 280 for the humidity, air pressure and temperature, a UV sensor, a gyroscope and accelerometer. The data from these sensors are stored on an SD card. The middle port has the GPS module and LoRa module. The 1200 mAh batteries connect to the bottom port, which also has an ESP microcontroller to control the camera. We save pictures to an SD card, which is different from the top port. We utilize 2 batteries connected in parallel to increase the amperage.